Hello guys and welcome back. So let's keep on going. Now to be able to spawn the fruit, we need to have a arena, right? Now we just have the box here. That wouldn't be enough. We want to actually have an arena here. Okay. So to do that, it's probably better to just create an arena class, right? I'll right click here and create a new C++ class. And this again will be actor, but maybe we can save some time and say this arena will be a, let me check, show all classes. Static mesh actor class. Okay, because that's the type of the floor. As you can see, it does have a mesh already added. Okay, next I'm gonna call this guy arena class. Arena should be fun. Create class. Reload all. Okay, so here in the header file, I'm gonna do a public. I'm gonna do that in maybe in the. Whoops, I'm having the trouble again to save it. I'm gonna close that and close that. I have to reopen it here for some reason. Arena. Right, again, public column or just column. Right, so for the arena, we need to know, or we need to set up the size of the arena, right? So let's do a arena and then that. Okay. Now here, for the arena, we just need to know the size and define the size maybe. Okay, so or I think the important thing is we set up the mesh, and that should be a bottom floor, and it should be having some dead zones around it, so we need to have that to be done automatically for us. Okay, so I'm gonna go ahead and copy that and go to the arena CPP or a arena column a arena right, parentheses here. Okay, so mesh. Okay, the mesh will be get static mesh component. That's going to be the mesh component that's already added in the a static mesh actor, so we don't have to add another static mesh. It's already in there. To access it, we can just call it, right? So get static mesh component, and then we're gonna set static mesh, right? And then the mesh will be again the cube, so I'm gonna go ahead and find that by using the, I think fruit is doing that, so I'm gonna copy that. Mesh for mesh, right, should be fun. So here we just switch that to get static mesh component. Right. That's gonna make the mesh to be the cube. Okay. All right. And then we need to, in the begin play, we need to know the size of the cube and everything. So I think what we can do is we can, in the game mode, we can set the size of the arena, right? How big it is. And then the arena itself will be able to generate, it will be able to create 4 dead zones on the 4 border. Right, let's see if we can do that. Okay, so here I'm gonna do that in the begin play. Void begin play. Okay, so this is kind of like procedurally doing our arena now. Let me copy that. I'm gonna say void a arena begin play. Right, so we're gonna set it up in here. Okay, first of all, super begin play. Okay. All right, and then we need to know our size, and that size should be already defined by the game mode. So we expect that when we begin play, we have the size already. Okay, so we can say f vector or f box, b box, bounding box will be get actor bounds. Okay, and then only collision components false. We don't need that to be only collisions. Origin and then box extend. Oh, I don't need to create one because it doesn't really return one. I have to actually create a f vector for origin and f vector for extend. Okay, and then I have to pass those two things, origin and then extend. And this will give me, this will populate the two variables I gave it and change those two values to the actual origin and extend of the bounding box of the actor. Equal child actors equals false, that's fine. Right. So I know now how big this is and where is the origin. Right. Now with that I can find out the 4 edges. Right. So I can spawn 4 dead zones. Okay, so I need to include dead zone dot h. Okay, so I will spawn those 4 dead zones, and I guess I need to just remember their location and position. So f vector maybe we can do that with, in 4 times. I'm thinking if we can do that with a loop, but maybe we don't have to. Okay. I'm gonna create a function here called void spawn dead zone or spawn wall. Okay. Void spawn walls. This one will be private because we don't need other ones to access it. Okay, spawn walls, spawn wall, right? And then need to know 2 things: vector spawn location, and then another one spawn spawn scale. Okay, I'll copy that. And then I'm gonna implement that void a arena column spawn walls. Okay, that's where I'm gonna spawn a wall. So with those 2 information, I can spawn a wall, right? That's something we know how to do that. You can see I'm simplifying my steps into individual functions, and one function just takes care of one thing. In this case, this one just takes care of spawning a wall, and all I need to give it is a location and scale. And for that location and scale, when I'm spawning here in the begin play, I will try to figure out the values for those things. But now to spawn one, I can really implement that real quick. So I'm gonna say get world, right, and then spawn actor, and then a dead zone static class, and then spawn location, spawn f rotator for the spawn rotation. I think I can specify the spawn scale, isn't it? Spawn scale. I need a transform for that, so I need to do a f transform. Spawn transform b equals to, or I can define that here, f transform, oh, not transaction, transform spawn transform will be equals to f transform, and then we can create one here with some variables. I just need to define rotation, transition, and scale, right? So spawn location. Oh, rotation first. Vector register. I don't think that's something I need to create a special type, just F rotator. And then spawn transition will be spawn location, and spawn scale, right? Okay, and then here we can say spawn transform. Instead of 3 different size, 3 different translation or transforms, I can create a spawn transform which takes care of the rotation, location, and scale into one matrix, and then I can pass that along, right? And then spawn parameters. It should be a default setting. Yeah, that should be the easy form to do this. Okay, so again, this transform will include all 3 things: location, scale, and rotation, right? Rotation wise, I don't really care, right? And this is spawn location that I do care. All right, and then also the things we're spawning. I don't even. Maybe we can set the owner here just like that. I think the other things before I can do F. Actor spawn parameters, spawn params. Just like how we do the tail, I can say spawn params dot owner equals this. I spawn parameters dot collision. This is the things I really worry about is the collision thing. So this will be always spawn. Right? And here I can do a spawn parameter here. Okay, so now we're spawning the transform. Whenever we call this function, we will be spawning a dead zone based on the location and scale we give it. Okay. All right. So scale will be like longer, or on the vertical or horizontal direction in this case. So yeah. Now let's find out where do we spawn those things, right? So let's do that. So I know the origin, I know the extent, like how far it goes, right? So I just need to use origin to add extent x to know the left side, extent negative x to know the right side. So let me do that. Vector left middle, or left wall location. Yeah, that's a better name for that. Left wall location will be origin, right? And then it's going to be minus extend dot minus extend actually f vector extend dot x, and then the rest will be 0 0. Okay, we're only caring about the x-axis. Right, right wall location, left, right, up wall location, and down wall location. Right wall location will be negative extend x. Oh, actually plus should be fine. Yeah. Now up will be plus on the y. So that's gonna be 0, and then extend dot y, and this is going to be 0 here, and this one with the y-axis will be extend dot y. Right, so up and down, and yeah, so that's all the wall locations, and we should be able to spawn those walls. We need to know the scale, of course, right? F vector left wall scale will be equals to extend f vector, right? Extend dot x times 2. I think that's the that's the size. And I also need to know the wall, because the dead zone here, they don't really have a mesh, right? I probably need to do that. We're doing the same thing, so we're using the cube here as well. Okay, so spawning here, right, we can say a dead zone pointer spawned dead zone be equals to that, or spawned wall maybe. And then spawned wall dot or set static mesh. Oh, mesh, set static mesh. Will be equals to our mesh. So because we're all using cubes, we can just get it from here, but that wouldn't be ideal. I think we can also define it here. I think the wall should not be a dead zone. Let's create a wall class and we can do it in there. That way it's easier for us to define the wall to have a different different mesh if you wanted to, because this is not the same. So yeah, this will compile anyways. So let me go ahead and add another one that's derived from the dead zone. Create blueprint class based C++ class based on that. I'm gonna call this guy wall. Okay, create class. That way we can use wall and we can define things in the wall, because that's the wall's stuff. I mean, for the tail, I think it makes sense for the tail to just use the mesh of the head, right? There's no problem on that. I can change that maybe, of course, as well, but for the wall, I think it doesn't have to be the same as the floor of the arena, right? Okay, just in case I will crash there. Let me close those things and reopen. Okay. So here for the wall, I'm gonna do public a wall. Okay. And then I can say a wall. Your mesh will be something I can define if I wanted to be differently, but I can copy what's happening in arena here. Or maybe from the fruit, because I kind of want it to be exactly like the fruit. In this case, they're all cubes, but I can change those things later on, right? So I also wanted to make sure that the size of the wall is, to start with, a wall, right? When it's constructed, the size will be a 1 unit size. Okay, I can define the wall width and wall width and height. So let's do that. Private wall width, which will be a float. Float wall height. For the wall length, I will make it 1 first, and then the arena will define the length by scaling it on that direction. So float width and height is going to be the one that I'm really care about, and we can make them something here. Wall height will be equals to 200, and wall width will be equals to 50. So it's 200 unit high and 50 units wide. But then for the actual size to start with, I'm going to make it 1 unit, right? So I can say I'm trying to make it more general, but maybe it's an overkill here. Maybe because it has to be a cube to work this way. Okay. Yeah, I'm overthinking it. So I'm going to do mesh dot set scale, relative scale 3D to be f vector 1, right? And then I need to use that to divide the actual size of the mesh's bounding box. So mesh for mesh dot object get bounding box dot size get size. Because the cube is not one unit. I think the cube is not 1 unit. I have to normalize it to 1 unit size. So this will make it 1 unit size wise. Okay. All right. So if the size is bigger here, right, if the actual box is bigger, I'm going to scale it down so that the whole mesh is 1 unit. That's easier for me to deal with the arena now. Right, so it's going to be wall, and there's going to be wall here, a wall. Okay, so we're spawning wall now. You can see it's not that hard to switch to other types. Okay, so the scale then will be extended x times 2. That's the since on the scale on the x for the other ones will be, you know what? The wall size, I think I can define them not in here. It should be in the arena class. It's easier to define it in there, right? So float wall height, float wall width. Okay, we can say wall height will be equals to 200 and wall width will be equals to 50. Okay, now we can define the x as the should be defined already. I think it's just having trouble catching up. Yeah, so f vector, we make it x, which is the length, right? And for the other ones, the height will always be z. So the y will be the width, so 50 wall width and wall height. Okay, and with that being, those things being figured out, I can then call spawn wall. Right, and then we can say spawn wall's location will be left wall location, left wall scale. Right, we spawn 4 walls. We just repeat that. So f vector left right wall scale will be equals to the same as left wall scale. Right. So I can say, let's call this vertical wall, because the vertical walls are the same, right? Same scale. So I can just spawn wall again for that. So that's gonna be right wall location and then vertical wall scale. Right, that's spawning the left and right wall, and then for the up and down walls, we can do the same thing. Can figure out the vector horizontal wall scale will be equals to f vector. Horizontal one will be also just very similar. Wall width will be the x extend dot y times 2 will be the length now, right? And wall height will also be the height. And then we can just spawn wall. And then it's going to be up wall location, right? And then horizontal wall scale. and then spawn wall again, and that's going to be the down wall location and then horizontal wall scale. Right. That way we're procedurally generating this. It's based on the cube. That's one unit. We're going to just position them and scale them differently, right? Based on the variable we passed in. The wall is using a cube for to be exact. And arena will be, we don't have anything here yet, so it's going to be creating an arena as one cube size. So in the game mode, right, in start play, we can create another function called spawn arena first. Void spawn arena. Okay. And then here we can implement that. Void AC greedy snake game mode spawn arena, right? And then we can get arena included. Okay, we can say get world spawn actor a arena, right? Now, of course, we need to know where do we want to spawn it. It's going to be in the center. That's fine, right? And I can probably define a size here. Okay, I'm going to do float arena with float arena height, right? Now that should be enough. Okay, right. I'm gonna say spawn arena will be doing a spawning, right? We're gonna spawn arena here, static class. Okay, the spawn location will be f vector nothing. Oh, let's do a f transform again. V equals to f transform, and then we need to define location, the rotation first, right? So f rotator nothing, and then translation f transform nothing. F vector nothing, and for the scale, right, that's when we need to define arena for the x is going to be the height, and arena width is x, and then the next one will be just 1 for the z scale. Okay, all right. So spawn transform. And then f actor spawn parameters, and that will be the spawn arena. So we do spawn arena here first. Okay. This is spawning the camera. Right, we probably need to do that and create a function called spawn camera. But yeah, we spawn arena after that. Okay. Let's see, that's a lot of code. I'm not sure if there's any bug. But again, you know, this is based on how confident you are. Sometimes I write a whole lot before I try it. That's not a good habit. But I just don't want to break up my thoughts, right? But you can do step by step, right? Carefully do every little step. Try play this. Okay, I'm not seeing any arrows. Did I got arrows down there? No, there's no arrows. So I should be able to get rid of that and get rid of that. Right, I can play this. Okay, what does it say? So the arena is here. There's walls, right? Arena here. Scale x and y are 0 for some reason. Oh, because 0, 0, I didn't define them. That makes sense. That makes total sense. So spawn. I'm gonna set the arena height will be 500, arena width will be let's make 700 here, and this is 500, right? Compile that, play this, right? You can let me hit F8 and zoom out, and there's something wrong. Let's check that. Okay, this wall, oh, I think the wall is not in the right in the right scale, so I didn't need to swap those scales. But other than that, let's check. The wall is the correct height, right? Okay, and again, the arena has one issue too. The arena should also be scaled down to the size that's proper, just like what we did to the wall. You can see we make the wall, right, set relative scale 3D, and that has to be done also in the arena. Otherwise, the arena is 700 times the size of the model, not the unit. So that's the problem here. And also when we spawn those things, I think I got the things wrong here. So yeah, if I change the width and height, that would be fine. So I need to put it in here instead. Just swap those two things for the input here. So this will be y now, right? And this will be x times 2 and wall width. Okay, but other than that, the other things are doing pretty okay. Okay, let's give this one more try. Compile, and we should have like a 500 by 700 arena created for us, right? And it's going to be having the walls placed in the right place. Now, how cool is that? So maybe we can add the scale to make them clipping into each other. You can see the dead zone also works, right, when we hit the wall. So we can make it just a little bit longer, plus the wall width. And that goes to here too. Okay, and also, what else can I do? Yeah, I want it to be bigger. That's too small now. So, see, that might be okay. Compile that. Split it. Now you can see we have a bigger arena, and it's all set up for us, right? That's something we can call procedural modeling even. Right, you can manually do those things, right? But using some code, you can just say, okay, my arena is too small, I want it to be bigger. You go to your code and you change your value there, and you don't worry about anything else, right? If you're building it yourself, dragging things in, assign them models and scale them, it's error prone, and whenever you need to change the size, it's not going to be guaranteed that you're going to have to change the size of the other walls as well. So that's 33 minutes. We do some, procedural modeling basically to get the wall laid out. But yeah, that's just one of the arena. Now this algorithm can be even used for, like, if I wanted to create a lot of other rooms, I can combine them together, finding walls and doors and stuff. Those all can be procedurally done like this. But let's not do too fancy here. Just this is probably too much for teaching a simple game like this. But you can manually do those things, don't worry. I'm gonna stop this now, and we're gonna go ahead and start setting up the actual generation of the fruit. Okay, see you next time.